Welcome to a new test and teardown video. This time it's an ABB Aztec 600 water test unit. So this one can test water for all sorts of contaminations. And they're using some special probes for some test samples or some activators and such things that it mixes into the test sample. So I believe this one is the test sample. And here is a really cool solenoid valve system that will connect one of those inputs or outputs, of course it's two-way, to a single common. This common hose then goes to the sensor. And I'm so sorry it came in this a little bit sad shape. So we got one cover here that is missing, and then this front cover is missing. Also the different bottles of chemicals that's used to mix in the samples and all that kind of stuff. I don't have any of that. But anyway, maybe it can be reprogrammed and reused for all sorts of other things, because it uses a very simple measurement technique. And we can push this down and then pull. And then we'll get access to the sensor. And it's all about light. So there's an LED on one side, then there is a glass syringe in here, and then there is a light detector on the other side. We can actually pull up the LED. And of course there is a high accuracy current source for the LED. And here's the detector. And a little op amp plug this way up. Look at that. It is actually possible. No, it is not, because that connector is not in the sensor. Duh. And then there is this syringe and a gear and a stepper motor. And then here is a visible part of this shaft that is moving up and down, so we can see it's moving. Up here is, I think this is a standard PLC. We've got 6 buttons under the screen. And then the rear side of the display unit, there's an SD card and a button. So there is actually a little CPU and stuff like that all the way up here on the display. And then here's the PLC. We got relays for outputs. We got digital outputs. We got some sensors and sensor amplifiers. So we got temperature sensor amplifiers as well. And here we got analog inputs, analog multiplexer, and the classic filters, capacitors, and voltage dividers. And then of course the multiplexer. And a switch mode power supply. And this one of course delivers 24 volts, because of course PLCs, they run on 24 volts. And I believe this is the CPU. I think it actually is possible. Yes, that is the CPU. Nothing super fancy smancy. And then let me put this like that. Ooh, need two hands. So that was the CPU adapter card, and that one can't be mounted wrong, but if you look at the top here, look at that. A completely symmetric connector system for the CPU. So it is actually possible to flip the CPU wrong. Ooh. And here we got some more input output configurable. Oh, look at that. Ethernet module. Right? And we've got a little switch with enabled something. Enable, disable. The Ethernet. Expansion or programming. Some stuff like that, right? Maybe we should have a look under the power supply. It's a really beautiful PLC design. And 10 relay outputs. Very nice, easy to access connectors, and all that is super duper standard. Mains input is of course marked so that anybody can easily access this. There is actually a little bit of a tricky here. If you look at those, the screw terminals that goes to the power supply, obviously this is you have possibilities to upgrade the power supplies. You see mounting holes here for a bigger power supply module. But look at those two screws. You really need to pay attention here. See, the two wires goes of course to those two, line and neutral, and then this one is earthed. You could, if you look from this angle, and if you didn't see the text, you could think that it's this one and that one. That is the input. Ooh, dangerous. But here is the main CPU. And software. So that's probably an EEPROM, right? And that will be AD converters. We got some optocouplers. Oh, that's a really nice optical interface for the analog stuff. Yeah, they know what they're doing here. I kind of like it. It is really beautiful. And that is probably the... I actually don't know the difference between these two right now, but I will look that up. And of course here's a power supply for the local voltages. I think I just want to power this up and see what happens actually. And of course this one was more or less pulled up a trash container, I guess, because it really looks... Oh, I need two hands to show you this. See, all the mounting here is broken, and it's also broken in the other end. And the parts here is badly damaged. So that will be the cable for the solenoids, and that will be the cable for the detector. And here is the interface board, and of course they got many different of those depending on what is going to the PLC, and I believe this PLC is more or less a standard PLC, but this one is of course specially made for this product. So we got some different end of or high level, low level, or out of this or out of that kind of sensors. Clean this or clean that. So there's also some stepper motor stuff there. So yes, I think I want to try and connect this and yeah, power it up and see what happens. And of course you're going to be with me at the very first power up. 13 watts, 12. It boots up, 12 watts. And look at that. Oh fuck. Oh, solenoids! And it's going in and out. Oh, it's an infrared! No, ultraviolet! This is... What is this? Diggity-daggity. Look at that. It's measuring all sorts of things. Oh, we got calibration. Aha! It measured calibration standard empty. Yes, everything is empty, my friend. So, and then it goes to another solution. That is so cool. Okay, so it's moving. The piston, I can really feel all those clicks that's in here. So it's going slowly in or out or something. I don't know if this is normal. But wow, there's a beautiful ultraviolet. And then what? Are we done? What are we seeing here? Ha! Contamination. Wow, I think it is working. Replace, how do I do? Okay, so this is back. Oh, look at that. Configuration, operate this and diagnostics, and then relay test. We got all sorts of cool things that's going on here. Wow, nice. Let's do the relay test. So now they're all... How do I start this? Maybe you... Ah, look at that! Click. Relay. Alarm relay. Ah, I heard a relay in here. Oh, we got a relay. We got 2 relays. Click. Off. Only 1 relay. Okay, so that will be the alarm relays. All right. That's interesting. I think I can figure this out. Well, let's go and get some funny solutions and stuff. So, that is some different values, but without the calibrations, we're not going to get any kind of feedback. I'll play a little bit with this and see if I can get some values from the sensor. And my idea is to try and put down a piece of paper and attenuate the UV and possibly get a variable readout from that detector. That will tell me that there's a possibility I can carry on with this unit. I think I found the bug. And that is why we heard those stepper motors going in and out and continuing after it was going all the way to the end. See, now I am in another diagnostic, and see here, piston origin fault. So it's going all the way to the origin, and it's the fault is the detector. So that means it don't know its current step. But other than that, we see sample detector is 0, LED current and all that kind of stuff. Yeah, it looks like I'll be able to continue with this, here is calibration, here is IOs, some more information. Very, very interesting to play with. Here, calibration, last gradient, sample, detector. Okay, so that is not. Well. So here is the detector before I open it. And the first thing that I find is that it was actually assembled wrong, because look at those cables for the stepper motor. They are just completely squashed to death. That is not how you do that. And also, look at that mark. It's not so much here, but it's much more here. Look at that. Look what that means. This is the end of that screw that was supposed to be here, that just was from the other side, and then just screw, and then just let's just poke around with this until it goes through, right? Oh man, why don't people pay a little bit attention to what they're doing? I mean, put it the right place and then the screw through, right? Yeah, but I think we got, yes, 2 more screws up here, and then I will be able to look inside. Oh no, it's a sad day. Look at that. All this plastic here is completely cracked. So that is from over tightening those 2 screws for this top cover. And all this cover does is just doesn't do anything. It only covers the stepper motor here, and honestly it's going to run perfectly fine without this cover. So how do I get more in? There's supposed to be an end stop sensor somewhere, right? So inside this unit here is the stepper motor assembly, and I unscrewed the stepper motor, and here is the hole for the light. See, now I can move this out and see the piston. I'm a little bit worried about the dirt and the stuff down here. Maybe this is the rubber gasket that is completely dissolved, and that explains why this is not moving correctly. A big solid chunk of aluminium, and then there is actually a heater. Oh, thanks, love. Oh, gotta go. That is a little bit interesting. I don't see any sensors anywhere to detect where's the piston. So that is really weird. But I see here on that PCB here a temperature sensor, some power resistors and some power transistors, op amps and all that kind of stuff. And obviously we got, here we go, 1 power transistor. No, this is a power resistor. And then there's another power resistor here. So what they're doing is they're heating up the test area here. I think this is just to avoid everything from freezing, because of course they're going to be able to run this on the, like, in winter time, right? But I don't see any sensors. Maybe there could be like a magnet or something in this one, but I don't believe that, because how is that going to work? Could this? Well, that one. Nope, that's an op amp, 358. Oh, so how the heck is it detecting the piston, and how is it causing this piston fault? I don't see it. But can the piston really move? So okay, that is screwed here. So that is what I need to play with. And I definitely need to clean this up. Okay, so I figured out how this is assembled. So we got an O-ring inside this end piece. And this sticks, of course, into this aluminium part there, right? Then this glass part sticks in. Let's just attach to it. So there's an O-ring up here as well. And then, of course, this shaft here is held somehow. This is held by this groove. That is, of course, how it works. So that is why you definitely need this unit. Aha! So if you unscrew this one, then you can adjust, you see, the position, the minimum and maximum, because this one rotates then. And this one is, of course, there's a hollow shaft inside the motor with a thread that matches this one. So when the motor rotates, it's the same as doing what I'm doing here, right? Then we move in and out here. And then I'm actually trying to brute force this by pushing here. Yeah, you see? Really, really hard to do. But of course it's dry, so I want to try and make it a little bit wet just by using normal water and see if I can get it to move. So now it's cleaned and a little bit wet, and look what happens. Now it moves. See? You get a long way with a little bit of lubrication. So all I have to do now is assemble this whole unit. And probably it's going to detect the end somehow. So here's the wires. I believe this is the right way to mount the wires. So now they can't be in the way. So they're supposed to be in here. And now there's plenty of space to put the cover on. See? Clickety clack. And then the wires are perfectly nice and shiny. So probably somebody was in here and poking around with this, because there is this end stop error. I hope it's gonna work a little bit better now, but how do I know? Because I didn't find any detector. So I got it back assembled and everything is perfectly fine. It can move and all that kind of stuff. And of course in the cell diagnostics I find this pump reset, and when I run the pump reset feature, it is actually doing, of course it's not gonna run it again, how annoying, but it gives me this error. And when I go back to the error list, that is this damn sensor that is not working, and I cannot find the sensor. Oh, how annoying is this? So I mean, it stops my quest for tonight. I'm a little bit sad about that. So there is some sort of a sensor or some sort of a method it uses to detect, but I really don't know how that works. I didn't find anything. How is that working? How can this trick me? But the motor works perfectly fine. It goes both in and out and all that kind of stuff. So if you happen to know this, please comment on the video so I can progress. Because this is a little bit annoying. It could be cool to use this to detect all sorts of things in. But of course I can just use my own kind of way to do that. But it's much more fun to use it as it is, because it's really cool. I'm so sad about that. And I went all the way here. Then you go select, bring in, or release out, pump, reset. See? So if I select this, then I can activate. Yeah, see? Then it went a little bit out. Well. thank you very much for watching so far, and I hope you know how to fix this. Otherwise, I'm just gonna throw it back in the dumpster. See you around. Bye bye.